This conference will now be recorded.
So now, okay, let it be there. So first thing is there was a good PPT. I have prepared a PPT for you first of all to get some more idea about this. To add few more points to the yesterday's session, but before that, what is that is one more thing needs to be discussed from yesterday's session. What is it? So that is about. So we have just tested. We have introduced a sequence. We have introduced set. We need to introduce map. Once we do that, then we can switch to the discussion of sequence and the immutable and mutable type hierarchies, and also the differences and how exactly they are useful to us, all that stuff. Okay, because already we have a formal introduction to this, uh, to these tribes here. So there's a sequence. We know about sequence now, not in detail, but a high level understanding. We know about set in high level, and we know now we need to talk about map. This is where we stopped yesterday, and now map. What is map here? 1 minute, guys. Thank you. So map. What is a map here? See, the point is simple. When you talk about map, map and set has certain similarities. See, both are not indexed data structures. That is one thing. Second thing, internally, when you talk about set, internally, set uses mapping. That is one more important. But anyhow, that is a too deeper analysis. But at high level, now we can discuss a couple of things here. What is it? It is a child trait of trouble again, same thing, that doesn't change. That is first thing. Next one. This is also dynamic, no doubt about that. And third thing, how about duplicates? See, one more important thing about map here is map is used to store data in the form of key and value base. It is not like sequence, not like set. This is altogether a different data structure. Like it is like a dictionary. You know dictionary, right? I'm talking about the real dictionary. When you look into the dictionary, you can see there a word and a meaning. Now, if you see, if you think that word as a key, meaning is the value. So map is also something like that. What happens in map is map stores data in the form of key and value pairs. So map stores data in the form of a key and value pairs. That is one thing. Second thing, another important point is what is it? Here keys are unique and values can be duplicated. So we cannot have duplicate keys. So the point is keys are unique here. So keys are unique means no duplicate for keys. You cannot duplicate keys and values can be duplicated. It depends. If it is necessary, you can have duplicate values. Otherwise, we can leave it. Okay. Next one. So insertion order. Again, it's like set, right? Insertion order is not preserved here. So that is one more thing. Insertion order not preserved because it doesn't use indexing. It uses keys here. Okay. And for that keys internally they use some hash code. Okay. So in that way, insertion order is not preserved here. That is one more important. Then what else? So we know, right? We talk about duplicates. We talk about insertion order. We talk about unique, the basic behavior of map here, how it works, right? And anything else? Okay. And heterogeneous. Of course, your keys and values can be heterogeneous. That's up to you. It depends on your requirement and necessity. Okay. Uh, both keys and values can be heterogeneous. And there are certain rules when you are having heterogeneous elements in Scala. Today, you are going to have a very clear analysis on that. Today, we are going to see that you are going to get more deeper understanding of many things. So both keys and values are heterogeneous, can be heterogeneous. It's up to you, okay? And it's up to the requirement. There is nothing in our hands. So let's see one small example. First, we'll quickly do one simple example. Then we will switch to the discussion of sequence hierarchy. Then we understand both the packages like mutable sequences, immutable sequences. When I say mutable sequence, immutable sequence means that whole hierarchy with immutable classes, the whole hierarchy of sequence with mutable classes. What are the differences? And we also see the performance issues. So and the comparison analysis, all that we see here. Okay. One small quick example before we do that. This is at high level. And also one more thing is when you look at this hierarchy, right? When you talk about so if you look at the hierarchy here, look at this. The one at the top high level, okay. These are no. If they have both childs as mutable and immutable, like you see traversable and mutable. So they have set as as a child and map as child and sequence as child. Even when you get into the next one, okay, when you get into the one more thing here also you can see traversable, iterable, set, map, and the sequence. When you look at them, what is it? So these are having both their childs as mutable classes and immutable classes, or mutable traits and immutable traits. These are partially mutable or partially immutable. Got it right? So you can just think like that because as they have both kids, mutable and immutable kids, so you can assume them as what? Partially immutable or partially immutable. That's it. Okay. That is one more point just to be noted. That is one thing. Next, a quick example on this first of all on map. Then we got a high level understanding about map. What is it? It's the basic thing about map is it is used to store data in the form of key and value keys. And keys are unique and values can be duplicated. And you cannot duplicate keys here. Okay. And insertion order is not preserved. And keys and values can be heterogeneous. That is one more thing. We'll just do a quick program. We have already done it if you remember while discussing the options concept. We have just worked with map, but for now, a quick walkthrough with that. And one more thing, yesterday I think I gave you, an opposite information on importing packages. The point is, the immutable classes. I think if you don't import the immutable package, still that will work. For immutable classes, we must and should work. But anyhow, to get a better clarity whether we should import for both immutable or immutable classes, or by default, whichever the classes we use in the program are immutable or not, we will just test with the classes, with the flow, and we get a better idea. It's not something, it's not an emergency situation. We can understand it just by doing a couple of programs. Okay. So, but while doing some, while I was trying to test some samples, I understood that I have given an opposite information to you people. So default, when I am importing immutable classes from immutable package, it's working without importing them. If I am using them directly without import statements, the immutable classes, that is working. But for immutable classes, if I am trying to work with them directly without importing, then I am seeing some issue. You got it right? So the point is simple, sir. What is it? Based on that, whether we should import or not, explicit imports are required, or can we depend on implicit imports? That we can check when we create an object in the class itself. So now I am just creating object for which one? Map. Some map equal to, right? These are all behind this. There will be certain companion objects. So what is the point is, don't try to create, don't apply new operator here, right? You get an error. So something like one comma, we have to separate key and value pairs with this arrow mark here. How do you add this key value pairs? They are separated with arrow mark in this Scala. Okay, 2 comma something like 2 comma 3 comma. I'm just taking just 3 elements, 3 key and value pairs, something like 3, something like this. So this is fine for us. Now I can extract each element from the map. Now what is these keys are very crucial here. You can add something to a map, or you can remove something from a map, or you can what is it? You can modify something in a map. So you can do all this kind of update operations, or read operations, or write operations, or select operations. So everything is done through these keys here. Okay, we use keys to do that. Okay, we got the point, right? It's like, in sequence, if it is indexed sequence, okay, what is that we do? We use this indexes to insert something into that index sequence, or read something from there, or update something in that. Similarly here, instead of indexes, we have keys here in a map, and whatever we do on map, we do that with these keys if they were mutable. Mutable maps can be modified. Immutable means we should check it. I need to check once. Okay, I'm not sure. We will check it. That's not something to worry. So we can just quickly do what? Print ln of something like map of one. Let us just test it. Then I'm just trying to use keys here to extract the values. 3. Now run this. Now I got 1, 2, 3. So if I pass key as a parameter to this map variable here, then it is returning what to me? It is giving the value. Got it right there. So we access elements from a map, or we do any write, or we do any update, or we do any remove, or we do any all these operations on a map through keys. If it is mutable, then we can perform write or update operations, or remove operations. If it is immutable, I don't think so. Immutable means we cannot modify it. So we will check it once, okay, whether we can do that. Usually immutable means we cannot modify it. We will discuss that. So this is a quick idea here, sir. Got it right? Can you please check it once, test it quickly, and then I will switch to my example to this sequence topic after that. Okay, this is on a high level about map. Okay, all of you are clear on till this one, sir? Are you good till this level? This is only high
Yes,
level.
Manohar.
We are not. Yeah. So please test it. Then
Manohar,
we will jump to the. Yep. Yes,
Manohar.
Bharat. Yes.
Yesterday we have worked on sequence and set, right?
Yes.
And
Yes.
in yesterday, when we are printing the set, we are getting the sequence in a different format, not on the format what we are inserting. You said that you'll be getting that information.
Correct.
Is that going to be updated in future, or have we skipped that one? Just want to ask.
Pardon. One minute. Can you please, can you please repeat the question?
Yesterday, when we are working with set and sequence, while printing the set
Okay.
and sequence, the sequence order is the same way we inserted the data, and the set data is somewhat disturbed, assorted one.
Correct. Correct.
You said that you will get that information. Is that, have you skipped that one, or you will be teaching that in the near future?
No, we are not skipping. Asking about the comparative analysis between sequence and set. Is that the point? Am I correct, Bharat?
No. See, if we are inserting the values into set has 1, 2, 3, and so on up to 9. While we're
Okay.
printing this set, it is showing as 5, 1, 9, 6, 2, 7 in the random
Correct.
sequence order.
Correct. Correct.
Uh, Yesterday you said that you'll be giving the information on that.
Okay.
While it is printing in the random order.
See, random in sense. Yes, yesterday the one point about it is whether it is using index or whether it is not using index. I told you that I will update today. That is the point I told you, if I remember. Correct?
So,
Yes.
Bharat, I think the set is it is not in ordered; it is unordered. I think that point covered by Manohar sir. What
Okay.
he told yesterday that for loop how it is indexing. Anyway, so that order is
Okay.
that is always it is not in sorted order. It is in unordered.
But
It is not in
yes,
order.
yes. Yeah. Madhu, that's thank you. Bharat, anyhow, that set hierarchy we will do in detail. There is again, we start discussing everything with more examples, more scenarios, more use cases. So, if there were any doubts on that, probably I have given clarity yesterday, Bharat. I'm not sure if I missed anything, but still there is no point of skipping anything. We are not going to skip anything. That is for sure. And we didn't finish anything with sets. We didn't finish anything with sets. That's just only a high level introduction to every topic. Just we are introducing the characters. That's all. Again, we have to study each character again in a deeper this thing. Got it
Okay,
right, Bharat?
Manohar. Yeah. Thank you.
Whatever we have done in yesterday and today till today is just introducing the characters. But again, we have to study each character one more time. That too, the character has many subclasses. Again, we need to understand those subclasses as well. So definitely, if any doubts were there regarding that, maybe set or sequence or even map, everything will be cleared when we keep doing things. That's for sure. I can assure. I can tell it with confidence. Okay.
Thanks, Manohar.
Yeah. So please test it. Then also I will share those videos so that might be I think I have given clarity, but still that videos might have that information. If anything is missing, still we can discuss. Nothing to worry. And if you want to iterate it, we'll just quickly try to iterate this as well. Something like and you can see there, right? We are getting each key value pair when we iterate it like this, and this is called as tuple. Let's not get into too deeper into that. Just test it. It's a singer. Each pair. Somebody. Okay.
Madhu,
Iterating map. See here, when you iterate it, you can see every key value pair is put it into one bracket. I'm not going too deeper into this. This data structure, you call this as tuple here. You call this as a tuple. Okay. Again, we'll discuss on that again. Okay. If you are done, then I will switch to the little more deeper introspection of these things. Okay. Are you done with this, sir? All of you? Now, I'm getting into this now. Let us talk from here. When you talk about scalar collections, you have traversable and iterable, and from that these three are inherited. What is it? Sequence, map, and set. Okay, that is one thing. And you know this. For now I don't. So you are good with this. You don't have an issue there. Okay. Next one. Is it visible to all of you, or should I make it little? Should I go to a slideshow?
Visible. Hello.
Next one. When you talk about this, you can see here. So what is that? See, a sequence again. It's a sequential collection of elements. You know, we had discussed this. And one thing to get more clarity on this, there are two chains for sequence. One is indexed, which is more like arrays. The other one is linear. When you say linear sequence, that internally uses linked list. So these linear sequences internally uses what, sir? They use something called linked list data structures. And this indexed sequences uses arrays as data structures implicitly. And map, just now we have discussed, is a collection which has key and value pairs here. Like, you know, if you have idea about Java map or Ruby hash or Python dictionary, if you don't know, leave it. We are going to have a detailed discussion of every hierarchy. And set anyhow, you know, right? This is something which doesn't have duplicates. We had a discussion on that. And one more important thing is, in addition to these three categories, you know, you can see here there are few useful collection types like stack, queue, and range. That is one thing. And there are also few other classes that acts like collections. So even though they are not directly, you know, into this, they act like collections. That few of them are like tuples and enumerations, and you know about option and sum and none. You know about these things. And try success and failures. This comes with exception handling. Okay, got it right? So this is a quick idea. Maybe you can ignore it for now because you need to get an idea about this. That you know already, as we had a high level discussion from yesterday. Next one after that is so 1 minute. This got stuck. Okay, right. Next one. So now the question is, you know the hierarchy of sequence, right? When you are talking about the hierarchy of sequence, this is the sequence hierarchy. and it is there in both mutable collection and immutable collection, and it behaves differently for mutable and immutable. Observe carefully. If it is immutable, the first one is immutable. If it is immutable, sequence has these subclasses, indexed and linear sequences. Okay, and then you have here under indexed sequence vector, numeric range, string, and range. Here, just have a quick glance at it. And under linear sequence, we have list, stack, stream, and queue. And under linear sequence, whatever you have, this internally uses a data structure, which is nothing but linked list, implicit data structure. These are built internally with the linked list. And these data structures, vector, numeric range, string, and range, these are implicitly they are built with arrays, dynamic arrays, of course, not static arrays. So that is the important point. Now, when you scroll down a bit here, okay, when you get it down here, a bit here. Now you look at this hierarchy, and then sequence here again one more time. This time you don't find there are certain differences here. This is mutable. Okay, when you talk about mutable, just have a quick idea before getting to that discussion from the PPT. So this sequence has what linear sequence is there, indexed sequence. There are few more with immutable sequences. What is it? Linear, indexed, and buffered sequences are also there, right? And here in the linear sequence, if you see, we have these subclasses: synchronized list, and also mutable list, linked list, and double linked list, synchronized queue. Of course, queue is again a child. It's a trait which is a child, and from that you have synchronized queue. All this level at the left side, these are all linear sequences in mutable collections. And here, if you look at this indexed sequence, what do you have here in indexed sequence? You have array sequence and then string builder. Here we have array buffer. Observe, just have an idea. Observe here. Just look at the hierarchy. And buffer has again subclasses as array buffer, list buffer, and observable buffer and synchronized buffer. And these are traits which are in blue color. So I'm just showing you so that when you go to the comparison, so that you get a quick idea like what is there in mutable and immutable collections. Okay, now when we look at it, so when you are choosing a sequence, you know, right, you have two types of sequences. One is immutable and the other one is mutable. And the point is simple. When you prefer mutable and when you prefer immutable, it depends on your performance and your this thing. Okay. And when you say immutable, generally immutable sequences, they cannot be modified. Mutable sequences can be modified. You know, right, the meaning of immutability. So now, one thing here we have to observe here when you are choosing a sequence, like, you know, what are the features which that sequence should have here. So there are two things when you choose a sequence. So what kind of sequence you have to choose here? And now we have a clear idea. There are two types of sequences: indexed and linear sequence. So the point is, when you are choosing a sequence, point one, which sequence should I choose? Leave about immutability and immutability for now. The point is whether it is indexed or whether it is a linear sequence. This is point one. You have to see which kind of sequence you have to choose in between these two. What is that? Even it is mutable or immutable, because both have indexed sequence and linear sequence, right? So which kind of sequence you should choose here? Either the indexed one or either the linear sequence. That is one thing. Second thing, again see here now. Another decision you have to make it is whether do you want a mutable sequence or immutable sequence. That is another question. So even the same thing is applicable even for set or even for map, of course, with a different classes there, not index and sequence, because these are only specific to sequence. Okay, these two are important when you are choosing a sequence or when you are choosing a set. Of course, these features might change. Point is when you make some decisions. The second point is same for every collection. It might be set, or it might be map, or it might be sequence. Whether to choose mutable or immutable. Suppose if it is sequence, whether it is indexed or the other one is what's it? Linear. Right. So next one. Now this is a quick idea for us. A quick analysis. So when you see, these are most general purpose sequential collections we use in Scala. Most common, you might have a number of classes there, but among those classes we don't use every class regularly, but these are most generally used collections. You got it right? Sequential collections, of course. What are those here? One is, if it is a indexed, in immutable it is vector, in mutable we use array buffer. Equivalent to vector here is array buffer. Okay, and in linear, right, we have already an idea, just we had a clear discussion. It uses linked list. It uses for under linear, in immutable hierarchy there is list, and mutable hierarchy we have list buffer. So these are most generally used, most commonly used sequential collections in Scala. Now you got a clarity here, right? Under immutable vector and list, these are quite popular. Under mutable array buffer and list buffer are quite popular here. Most general used, commonly used classes here. Got it right, sir? Is that fine now? Now that's why I have asked you just to observe this hierarchy. And you can see here, list buffer is a child of buffer. Of course, it is again, buffer is a child of sequence. Got it right? And array buffer is, you can see, sir, array buffer is a child of index sequence, right? And that's it. These two we are using. These are the most popular in this. Which collection is this? This is mutable. Suppose if you go to immutable, now we know that, right? Here you can see immutable vector and list. These are most general, commonly used two classes. It doesn't mean that we don't use others. These are most popular, most general purpose classes. That is fine. I hope this is clear, right, sir? Switching to the next one. Now, when you look into the immutable sequential choices, there are so many here. You can see there. Under indexed sequence and linear sequence, we have many classes, right? Now, list comes under what? Again, you can check here. List comes under linear sequence. You can see that, sir, right? Similarly, like that, likewise, queue comes under. You can see here, it's ticked here. List comes under linear sequence. The sticks itself is clearly showing us which class is coming, is or which interface, sorry, which trait is under which kind of sequence. Is it indexed sequence or linear sequence? Suppose these are best choice throughout the hierarchy now. So what is that? List, queue, range, stack, stream, string, and vector. Now if you look at this, vector, string, and range are part of indexed sequence. Okay, and then stream, stack, queue, and part of linear sequence. What is the difference here? It's simple. Indexed sequence uses arrays internally, and they have exclusively, what is that? Arrays means, right, sir? So we had a discussion about arrays. They are best fit in certain cases, and linear sequence means these uses linked lists as underlying data structures, and these are best fit in certain cases. Now that is what we are going to understand. So let's quickly have an idea about list here. It is a simple single linked list. These are all data structures, sir. Might be you have heard about them in first year of BTech in C language. The one thing which most of the BTech learners, that graduation learners, which they don't like, is data structures. Okay, but they are very important. Even in data science nowadays, if you go to even AI or you go to the quantum computing, these data structures are becoming much more and more important. Even whatever we are discussing, collections are data structures. Okay, fine. So when you talk about list here, what is list here, sir? It is just simply a singly linked list internally. And usually this is best fit for what means you don't need to go through that all that stuff, sir. I can quickly summarize this here. This is best fit, you know, when if you want to add elements at the end of a collection or at the what beginning of a collection. When linked lists are best fit, if you want to add elements at the beginning or end of the data structure. Remember this point, sir. The basic thing. Anyhow, we keep talking, again and again. Automatically, you get that idea. If it is so, if your requirement or if your the goal is to add elements at the end or beginning of your data structure, then best fit is this linked list based data structures. Second thing, if you want to add elements somewhere in the middle, okay, or if you want to have best performance while retrieval of data, then definitely index sequence gives best. They are best fit for that. We will see one by one. Nothing to worry. You get more clarity. So this is what list will do. What is this? It internally uses single linked list, and it is best fit when if you want to add elements at the end or beginning of a list. Okay. Next one. Best fit, I am saying, it doesn't mean that you should not add in the middle. They are best useful if that is the requirement. And queue itself uses a principle here, first in, first out. The best example is a queue in a cinema theater. The old queue. Nowadays you are doing online this thing, but earlier you have to go and stand in a queue in a theater. Whoever stands near to that box office, they get ticket first, and those who stands at the end, they get ticket last. That is called first in, first out, and queue follows that. Okay, that is one more thing. Next one. This is again a separate sub hierarchy, a subtrait here. Okay? Range, it provides range of integers. Stack means it follows again, it is a data structure. This applies last in, first out. Usually these methods, right? The functions. Methods are executed from a memory array called stack. You remember, right? So what is this RAM using? RAM internally using this data structure. What is it? It implements all these operational activities, the processing functions, all that is done in the side stack. And we can create a data structure like this. That is stack. Okay? And it follows last in, first out. That is one more. And stream in generally, it's similar to list as you can see there. And they are introducing something really useful terminologies here. It is lazy and persistent. Persistent means what? Store elements, and lazy means only when you try to access data, then only something happens on that. When you try to apply some operation, till then nothing happens. That's called initialization or lazy execution. We'll talk more on that. Okay. Next, after that, string is there, vector is there, and you can see there. So we know about string. This is also immutable. We had discussed, and this is having index. We have worked with string and vector, and this is immutable again. But the point is what? Indexed sequence again, because we are talking about all immutable sequences only. So when we say immutable, everything is immutable here. Vector is what again? So it is also similar to list. The difference is it uses internally array here. You can see here. Can you see? Internally vector uses arrays, and there are best possible scenarios when we should go for this what is that indexed sequences, when we should go for linear sequence. Even I had made I had explored all that and prepared notes for you for that also. So this is simple idea here. Anyhow, I will go little faster here because just only we are just introducing these things. I am not doing anything, just getting in touch with all these things. Finally, which are popular sequence choice here in immutable collections? List, queue, range and stack and stream and string and vector. Okay, just have an idea, just have a look at it. You don't need to understand everything in this, or you don't need to get a, a quick everything in the description. We are not writing any semester exam here, so we don't need to worry too much about it. Okay, next one. Similarly, we have mutable sequences. In that, we have all this array buffer, array stack, double linked list, and list buffer. And again, they have two categories: indexed sequence and linear sequence here also. And anyhow, so for most of this, what is it? If it is indexed sequence, underlying data structures are what's arrays. Probably they use arrays. And if for linear sequence, they use linked list. You can see there everywhere. Now for double linked list, you can see linked list. For linked list, you see linked list. For list buffer, internally what it uses, definitely it has to use again a linked list. Can you see this, sir? That's all. Okay, let's switch to the next slide. And few more here. Even same from mutable this thing. What is it? A list buffer, mutable list queue, and then stack and string buffer. So these are all most used choices in mutable collections. Okay, fine. This is fine, sir. I'm just only what I'm again repeating. We're just introducing and just trying to register these classes with us. That's all. Now this is important. Whatever we have discussed so far, that is only just to show that these are important classes. These are important classes under immutable collections and under mutable collections. That is the discussion. But now, in this all, so in this whole discussion, the important slides are this. This is one important slide because this gives you a high level clear information about each collection here. And the last slide reminding. Okay, of course, they are also good. I don't say they're bad. And this is also important. Choosing what are the features you have to look when you are choosing a sequence. That is one more important slide. And also most general purpose sequential collections. What is that? And then this anyhow, this is generalized. You don't need to worry too much about this part. Okay. When we keep doing, you automatically come to know about everything. And even this also, these are all bunch of classes. At a time we cannot get into everything. It comes with time. Even these are all, and this slide is important. Now you see, sir. So the point is understanding performance of collections. So don't worry, sir. We can start to programs, but before that, you need to have that idea, like what are immutable, okay, which are most general purpose, and the difference between indexed sequence and linear sequence. When you start doing with sequence, all the differences you need to know. Now coming to this, if you see here, right, when you look at this slide, easily you can understanding the performance of collections if it is important to you. So when you should choose indexed sequence and when we should choose linear sequence, this is very clearly explaining this. When you want random access of elements, I had just made this point when we are discussing about the difference between indexed sequence and linear sequence. You remember, right? If your frequent operation is retrieval operation, if your frequent operation is retrieval, read operations, okay, that to random access of elements. If we want to access from anywhere, wherever you want, then go for indexed sequence. An indexed sequence internally uses arrays. That is one important point. Next one, linear sequence. Linear sequence means you can see, sir. Usually we use this linear sequence, linear access of elements. You can see. Linear access means, sir, you have to go for element by element, not the random access here. Even this is also best fit for retrieval, but when this is useful, when you are going from element to element. If you remember a linked list, I'll just quickly explain this with a small diagram to get more clarity. Suppose if it is an array, right? I'm not just to get more analysis. Okay, if it is an array has some index. Enough. We don't need many indexes. Something like 0, 1, 2, and 3. Now the advantage with arrays is I can access element from second index or third index or one index or 0th index by using this index alone. I can go and get whichever element I want without any issue. This is called random access of elements. Suppose I want second element, let's say what is that? If array name, assume that array name is A, then I can simply say A of 2. I'm getting the middle element. That is called random access. Suppose I want third element, I say A of 3. I get third. I'm getting third element. This is called random access. I can choose wherever you want and I can get it from there. Such ritual we call it as random access. Suppose you take linked list. Linked list will be like this. Something like it will have collection of nodes here. Every node has two parts, data part and link part. If you look at this, okay, every node has data part and link part. A quick idea. So, and every node has some address. Assume that this is 100 and this is 101 and this is 102. This has some address 101, right? And the address of this node, the front node here, okay, will be stored in this previous node. The next node address is put it into the previous node. Here you have 101 and here you have 102. Just to give you a clear idea. So now this has two parts, data and link here, okay, and again here you have two parts, data and link, okay, and here also you have two parts. Now by now you should understand, nothing to, you don't need to write it. Now this is pointing to this link, this is connecting to this is connecting to this list is a single linked list, and now this has null because no other node is there. This becomes null at the end. A null is stored, assuming that is the end of the list. Okay. Now, if you see by looking at both data structures, suppose if I want element of 100, I should come through some this one. Suppose this list name is S. Okay, the reference of list is S. Now S will hold the 100. Suppose if I want 100, now S is pointing. Then what should I do? I should try S of 100. Now after that again I need next element. Then I have to move from first node to second node. And again if I want third element, I move from where second node to third node. Now here if you see, these are called linear access. Linear access means now it's easy to access first element and then go to the next one, and then access that and then go to the next one. So this is best fit when you are trying to access elements in sequential order. Suppose I want something at the end. Even if you want something at the end, you have to start from the beginning. You should start with engine to next bogey and next bogey, and after that the last one. Array is not like that. Suppose I want to, I can get it from the direct. I can go to the index, choose the index, get it from. Got it right, sir? Is it making some sense? That is what this is explaining us. Okay. So the point is simple. When you want random access of elements, choose indexed sequence. If you want linear access of elements, choose linear sequence. And what about sequencer? This doesn't matter. Whatever, you just need to use some access elements. So you don't need to care about whether it is random access or linear access. Then go for sequence. Got it right? So that is an idea here. This is an important thing to remember, because of course nowadays in Spark people don't ask these questions, but knowledge is good for us, right? Understanding is always useful to us sometimes. Is this fine for all of you, sir? So this is, I think we are done with the introduction to the sequences. Got it right, sir? Now this is more detailed analysis about sequence today. Probably you should have your understanding towards sequence. So your clarity on sequence At least I can say it would have been improved at least some 20 to 30% from yesterday's session to today. Still, when we keep doing programs, you understand more, right? But finally, the easiest thing to remember is what is it? So sequences are nothing but what? They are used to store data in two ways, either in indexed form or linear form. Indexed uses what? It uses arrays internally, whereas linear sequences uses linked list internally. Okay, but still we can get more detailed analysis. Like when we go with each class, what would be the underlying for every class? We get more clarity. This is a generic idea. If it is indexed, usually they uses arrays. If it is sequence, they uses what's it? They uses linked lists. Still, if there is any difference, then we can capture that. We can catch that when we talk about each class individually. Is that fine, sir? All of you are good now? This gives more clarity here. Hello, sir. Did I make you people sleep? Yes, sir. I made you to sleep. Okay. Theory sessions will be like that, sir. When you talk, when you have more theory, but still we need to understand this fundamentals. Otherwise, what happens is
So I mean, I understand it clearly.
what is it, Madhu?
I ping it there, yes, right. So I understand it clearly to say that.
No, I'm just kidding, Madhu. I know that. So because this today whole session is more theory. I think it's very rare that we discuss. Not tomorrow, Suresh. Maybe within 1 or 2 weeks, I will update on that. Tomorrow we don't have a session. Okay. So hope we had more information today. I'm sure that I didn't put you people to sleep if I'm not wrong. So still, okay. Got it right? Shall I ask you quick questions? Let me bring out of your sleep now. I'm just kidding, sir. I know you might have focused and understood more on this today. So anyhow, this question is very basic question. If I ask this question, all of you answer. So what are the three core traits in our collection hierarchy? What are three core traits in collection hierarchy? Core traits. That is first question. Next one. You can answer, sir. Because I made you to listen so much of information today. Let me ask some questions so that you can map again to all that things. Okay. So next one. I got answers, okay, from 4 or 5 of you. No problem, sir. If you are clear, that's fine. But the answer also, it makes more happy for me. Okay, it is more happy for me. Which is the root trait for all traits? What is the root trait for all traits in Scala? So that we can call it as a root trait also. Okay. Next one. Now, when you talk about sequence, how many types of sequences do you have? I mean, I'm not talking about index and all that. We have two types here. What is it? Mutable and immutable. That is one thing. Second, also, what are the two core classifications of sequence? We have even some buffers there in some mutable collections, but we don't need to worry about it. I just only two core classifications of sequence. Can you answer that? Two core classifications. What is it, sir? Correct. Index and linear. Okay. So these are the two core classifications. We might have a few more like buffer. After that, we might have some more. So now you tell me, just on a higher level, if it is indexed sequence, what is the underlying data structure it uses for indexed sequence? Of course, when you go to the class level, it might change from few of classes might have different underlying data structures, but we will evaluate that when we do class by class. So basic thing is what is the for indexed data structure? Usually it uses what's the indexed sequence. What is the underlying data structure it uses? And for linear, what is the underlying data structure it uses? So this is another question. Index sequence uses, sir? What it uses, sir? Answer. You didn't get my question. Both uses some underlying data structures, right? What is that? No answer. So index uses arrays, right? And this one uses what's a linear sequence uses probably something like a linked list. This is discussed, right? Oh, probably you stuck it somewhere. Okay, you are thinking something else. We have a detailed analysis on this, right? That's why the conclusion is always very important. I have read it somewhere to improve the reading thing. You have prepared for 4 hours, and when you are just concluding at the end, last 10 minutes is very important. I had read it somewhere in some article. This is also like that. Okay. So next one, last question, probably last or one more, but one question. So when do you choose indexed sequence? I hope I would like you to answer this. When do you choose indexed sequence? Correct. Very good. Okay. When do you choose indexed sequence, sir? And when do you choose linear sequence? That is the next question. If you want to access, if you want to have sequence access of elements, sequential access, then go for linear sequence. If you want random access, go for indexed sequence. Okay. So now if you go and read any website, even I think most of these websites don't have this information, sir, because I have gone through some 4 or 5 websites and collected all this information, okay, including some famous textbooks. So that's why we got all this. Otherwise, I see that very few websites have better information, not every website, okay. So finally, this is idea about this one, sir, the introduction part. Tomorrow we start discussing about, right, I told you yesterday, this is much more interesting. You can see there, the interesting part is that tomorrow we start with the list, okay. List is now I have a question. Let me just check your concentration, sir. List is a child class of which sequence? I mean, which collection? Mutable or immutable collection? Is it in mutable collection or is it immutable collection? Please, sir. Anyhow, you are looking here itself. And one more thing, I told you, right? By default, collections in Scala are what, sir? Immutable. This I think I corrected that yesterday. I told it's mutable. By default, it's not mutable, immutable. Default collections in Scala are immutable. And you can see tomorrow, tomorrow in sense, Suresh, on Monday. Monday's session is more practical session. Of course, some very good theory points are there, but it's more of practical analysis. You can see, sir. Now you have so many methods to discuss. See, so many things are there. See, sir. I have covered almost all the methods of that. Which one, sir? That traversable. We have seen some 30-40 methods are there in traversable. So this is going, Monday session is going to be a hardcore practical session for us. And also you have more information which is very useful for us. You can see, sir. So all this is part of just one thing, okay? Part of this list class. And we are going to play with all that. And most of these methods from traversable, iterable interface and sequence sequence stride, all that gets covered here. This is a good, this will be, I don't think we can cover on Monday all this stuff. It's not possible. At least it will take 2 to 3 sessions to close this. By that time, definitely you're going to have a more, what is that? This thing. Got it right, sir? So, any questions, sir? So finally, you know that, right? A quick differences is sequence is usually indexed, right? That is what it is, and it allows duplicates, and also what incest order is preserved. Whereas set is not sequenced, and no duplicates, and incest order is not preserved. And map used to store data in the form of key and value pairs. So that's it. Hope it's clear for all of you, right? Any questions? Bharat, Madhu, Deepak, Sudarshan, Srikant,
Bro,
any of you have questions? Or Veer Prasad, Harish?
yeah, I have one question.
Okay.
Yeah, actually, that the sequence categorized into two types, right? So linear and indexed. So because
Yes.
with the index, all modes are possible. I know, so sequential, random, as well as skip sequential. If I am not wrong, skip sequential in the sense we first find range, and find, so we find range of the key value, and then from there itself we will read sequentially. So everything is possible
See,
with indexed. Yeah. But
even with the
when you use
linear
the
also, right?
sequential in that case,
Yeah, Madhu, that's what.
linear
See, even
sequence.
with
Yeah.
linear and sequence, both are, in both cases it is possible, right? But the point is when it is best fit. That is the point.
Yeah. If all possibilities are, so we can do all these things with indexed
Hmm.
when we choose that linear sequence.
That's what. It's right.
Yeah.
So there are some, see, we have got only very basic intro today. And if you go deeper into that, suppose if you are asking me, then definitely right. Indexed sequence to be more clear. Indexed sequences, like whatever it is if you see vector or a numeric range or string or range thing. Point is, these are best fit if you want to go for insertion, or if you want to do retrieval, or if you want to do what is that removal of elements. That is fine. These are best fit in these cases. But point is, when you go to the linear sequence is best fit when you try to add elements. That is what we call prepending and appending. It is best fit when you try to add elements at the beginning of the list or at the ending of that list. Right? Because to a linked list, it is easy to add element at the end, or it is easy to add element at the beginning. But it is again difficult. I don't say it's not possible. What I'm trying to tell is, if you add something in the middle, what happens is it has to move all the values from one location to another location. Frequent jumps are required for linear collection. So point is simple. So this linear sequences are best fit if you are trying to add elements at the end or beginning of list. Whereas indexed sequence are best fit if you are going for retrieval, okay, or if you are going for one more thing is what, insertion. So it is best fit for insertion and retrieval operations. Okay, like in the middle or random, right? Again, if you want to go for any random insertion or random retrievals, better you go for what? Random access. Otherwise, to be more clear, if you want to have a random access of elements, then you can prefer this indexed sequence. Random access means you can access anything from anywhere, or you can insert anywhere. That is fine. But if you talk about this one, linear sequence, it is best fit if you are adding elements at the beginning or ending. That is the difference. So that I will just show you. Maybe you asked me, right? I have today I bought this from Stack Overflow for you, expecting the same curiosity is there with me also. So when I was going too deeper here, now you can see here now. This gives more clarity. I see that after searching through the web thoroughly, this made some sense to me. See there. It is simply a super trait of indexed sequence and linear sequence. And then sequence is ordered list anyhow, you know that, as opposed to set, which comes in unique and unordered usually. You know about this also. And as opposed to map, which is a key value pair, you know about this also. Now comes to indexed sequence versus linear sequence. Can you see this now? So indexed sequence subclasses like vector, range, string, all are all fast indexed base access. Now this should give more clarity to your question. So you can see indexed based access and usually fast updates. Updates means insertion, okay, or adding, replacing some old value with new value like that. So this is possible because they use data structures suitable for this, like array internal. That's what I told clearly. Indexed data structures uses arrays, like in string or a tree. Otherwise, they use tree also in certain things like tree in vector. You can see there. For vector, it uses tree. I told you, right? Might be here and there might be some change for some classes, and our range, which is just numbers. For vector, it uses tree again. Okay, and about again for range, what is it uses? It uses something like it's like an iterator kind of thing, begin and end step. Okay, something like that. So which calculations of indexes are straightforward. So these are all indexed based. As these are all indexed based, the advantage is what to calculate the range of indexes, like from where, how many locations you have to push, where to insert element, and even when you do that, your algorithm should get all that also. That is why this is best fit in two cases. What is that? When you have a indexed access, when you have updates. That's what I told you, right? Random access or random updates. If you have that, prefer this. Otherwise, as opposed to this linear sequence, you can see that all slow index based and access. Why? Because linear sequence means you have to see what is that. It's not random, and right, it's internally they are using some linked list kind of data structures. So that's why what's happening is, if you add something, it has to make a, what it has to do is it has to calculate like the addresses, and then it has to see where it has to insert the element. All this kind of thing is there, so it takes more time for doing this. And you can see here are all slow index based and access. They are not best fit for what is this, for random access or random insertions. You can see slow in update, slow in access, because internally what they use is linked list kind of data structures. But so means these are best fit where prepend is fast for all of them. Means prepend means something adding at the beginning. For example, for queue or stack or list. Again, they are saying, and append is notoriously slow here. Can you see that, Madhu? Append is a notorious. Even append is slow. I told append for best fit for append. Even for append also, this is not best fit. Sorry, I should correct my statement. So means what? This is where we have to use this. When you want to prepend something at the beginning of list, then this is best fit. Even for appending also, notoriously means dead slow, as it has to go to the edge of that list. I told you, write this diagram also. So you can see this. Now from starting from S, it has to go to 1 or 2 address, and after that it has to add something. Even this is slower. So that is also means even appending is also slow to this. Got it right, sir? Madhu? except for Q, because Q has a different altogether. It has a different way of working. Okay, because it follows first in first out. Got it right? So finally, what is the point here? Broadly, indexed sequences are those data structures that have fast index based access and update. So if you want to have a access, best access means fast retrieval and fast updates. Update means insert somewhere modify data, then you go for this. Linear sequence are best fit, which where you need to have fast frequent. This is perfect, perfect statement. Madhu,
Okay, okay, got it.
does this answer your question now?
Yeah. So I'm clear about that indexed, so because all the access modes are possible with that.
Yes.
With the linear, yeah, so I got some doubt. So where exactly we use this linear sequence? Now I got it actually.
I
Thanks.
expected that doubt. Yes, I expected that question in the morning itself. So I prepared this probably keeping you also in mind.
Thank you, thank you.
Okay. So I think it's clear now, right? Now you can be more, this is more elaborative. So this should be more perfect for us to answer more doubts. Clear now? All of you are good, sir? I think today we have exceeded our time, no problem, because we are trying to understand important things. Thanks for the questions, Bharat and Madhu, and others also. No, just keep following. Shall we stop here today? How?
Yes.
Yeah. Yes. Okay. Thank you. Thank you, folks. We'll meet on Monday.
Mental panic.
Okay.